Welcome viewers. In this video we'll see the solved problem based on the coupled circuits. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Solved problem in the coupled circuit, problem number 7. We'll see the problem statement. Two coupled coil with respective self-inductance L1 equal to 0.8 Henry, L2 equal to 0.2 Henry have a coupling coefficient of 0.6. Coil 2 has 500 turns. If the current in the coil 1 is I1 of t equal to 10 sin 200t. Determine the voltage at coil 2 and the maximum flux set up by the coil 1. So the data is given are L1 is given 0.8 Henry, L2 is 0.2 Henry, coupling coefficient K equal to 0.6. I1 current in the coil 1 10 sin 200t. Number of turns in the second coil 500 turns. We need to find the two questions. One is determine the voltage at the second coil and maximum flux set up by the coil 1. First we will find the mutual inductance M equal to K into square root of L1 L2. K is 0.6, square root of L1 is 0.8, L2 is 0.2. By simplifying we got 0.24 Henry. Mutual inductance is 0.24 Henry. Now we'll go to the first question. The voltage at the coil 2, second coil. We know that the formula E2 equal to M di1 by dt. Two formulas available. One is based on the mutual inductance. Another one based on the number of turns. N d pi by dt. So the EMF is based on the mutual inductance. Mutual inductance means current. And so this EMF is based on the number of turns. Number of turns means flux. So here we are using M di1 by dt. So M what we calculated mutual inductance is 0.24. D by dt of differentiation with respect to t of current I1 and 10 sin 200t. So 0.24 into 10 is constant. The differentiation of sin 200t is cos 200t into 200. We need to differentiate again this 200t in the 200. So 200 into 10, 2000. 2000 into 0.24 is 480. 480 cos 200t. So the first question is the voltage at the second coil. E2 equal to 480 cos 200t. So the first one calculated. Now we'll go to the second question. Maximum flux set up by the coil 1. So let the flux in the coil 2 due to a flux pi 1 in coil 1 is pi 12. Let us consider the flux in the coil is pi 12. Then E2 also obtained in the following. We already told that E2 also depends upon number of turns. N2 pi 12 divided by dt. Pi 1 is the flux in the first coil. In that pi 12 of flux is linked with the second coil. Right? So 12 means the flux from first coil to second coil. So d pi 12 divided by dt. So N2 is given as 500. 500 turns d pi 12 divided by dt. We'll take this equation number 2. Right? So that we have equation 1, equation 2, both are EMF in the second coil. Right? So we can equate these two terms. These two, this left hand side we can equate. So 500 d pi 1 divided by dt equal to 480 cos 200t. I will go for the further simplification. Bring this 500 in the denominator of that side. So 480 divided by 500. It is 0.96 cos 200t. Now we will go for the further simplification. Now we integrate on both the sides so that we will find the flux. So integral d pi 1 divided by dt equal to integral 0.96 cos 200t into dt. So integral d pi 1 by dt is pi 1 to 2. So integral dx is x. Like that integral d pi 1 to is pi 1 to. 0.96 is constant. Integral cos 200t is sin 200t divided by 200. There 200 is available. So 0.96 divided by 200, that is 4.8 into 10 to the power minus 3 sin 200t. So the flux linked with the second coil from first coil to second coil, pi 12 value is 4.8 into 10 to the power minus 3 sin 200t. Now we need to find the maximum flux in the second coil. So pi 12 is maximum when sin 200t is unity. This term is unity, means we'll get the maximum flux, right? Then how we'll get the maximum? How we'll do that? Then in that case the maximum value of the flux is 4.8 10 to the power minus 3 Webers. If this term is unity, 1 means we'll get the maximum value 4.8 into 10 to the power minus 3 Webers, right? Now we'll find the maximum value. Our aim is to find the maximum value of flux in the first coil. This is the flux linked with the second coil due to the first coil. So by the definition, K equal to maximum value of pi 12 divided by maximum value of pi 1. Flux linked with the second coil to the flux in the first coil. This is the formula, pi 12 divided by pi 1. So what we need is pi 1. So bring this term in the numerator that side, bring the k in the denominator this side. So maximum value of pi 1 equal to maximum value of pi 12 divided by k. I will substitute the values. So maximum value of pi 12 is 4.8 into 10 to the power minus 3 and k is given as 0.6. So that 8 into 10 to the power minus 3 Webers, that is nothing but 8 milliwebers. Maximum value of the pi 1 is 8 milliwebers. So this is the second question, maximum value of pi 1. So in this video we discussed the solved problem in coupled circuit based on the inductor value L1, L2. We calculated M. Then we calculated the first question, EMF in the second coil. Second question, maximum value of pi in the first coil. Subscribe to the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. So in this we have L1, L2 and K values given. From these three values we calculated M. Then EMF we have two equations available. M di by dt. EMF is based on mutual inductance and current. Another formula N d pi by dt depends upon number of turns and flux. So by equating these two equations we got the maximum flux value. From that we calculated the maximum flux. Thank you for listening.